My name is Eberhard Farhbach. I'm a physical oceanographer in Bremerhaven, Germany at the Alfred Wegener Institute. And I'm responsible in this JC for the oceanography part. And in this oceanography part, you can imagine that there is many projects because the ocean is a very important part of the polar system. And in this presentation, I will just concentrate on two of that, still taking in mind that they are linked up with many other of projects addressing the ocean, not only in the physical sense, what I'm concentrating here, but in a multidisciplinary sense. So the two projects where I'm concentrating on, this is the project which is called The Climate of Antarctica and the Southern Ocean, CASO, and another one, the counterpart in the Arctic. This is developing Arctic modeling and observing capabilities for long-term environmental studies, Damocles. And these two sides of the ocean on the globe has to be studied because we have a global overturning circulation. And this global overturning circulation has two major sinking areas. There is in the Arctic the formation of the North Atlantic deep water, which is affected by the Arctic ocean processes, and in the south we have deep bottom water formation, which is affected by Southern Ocean processes. In between those sinking water masses, they have to come up, and this is happening in the Antarctic circumpolar current. So the polar oceans are really linking the overturning circulation together. But this is not the only part where the oceans are important, or the polar oceans are important for the global system. The global oceans, the polar oceans are covered by sea ice. And we are faced with the interesting behavior that in the north we have a dramatic shrinking of the sea ice cover and its thickness, and on the south there is really no trend to see. We think that an important reason for that is the different type of stratification in the ocean below the sea ice, and that's why we are studying this ocean. When we are studying those type of questions, we need to apply very novel technology, because the investigation of ocean under sea ice are really difficult to do. And so the Damocles project has a very important technical component where all type of devices which are measuring on the ice, under the ice, are developed and come at the end of Damocles of a, hopefully part of an ocean observing system. One example which is given here is the change of temperature in the inflow from the North Atlantic Ocean into the Arctic Ocean, because this heat, which is transported by the currents through the Fram Strait, which is the transit from the Atlantic Ocean into the Arctic Ocean, is increasing during the last decade. And we are wondering what is happening with this heat in the Arctic Ocean. Is it contribution to the shrinking sea ice or not? We further developed this system of observation now not only from the boundary but within the Arctic Ocean, and now for the first time this year we deployed a number of profiling buoys on the ice which are providing the stratification of the Arctic Ocean, and there we can observe what this heat is doing in the Arctic Ocean. Similar systems are needed in the Antarctic Ocean, because there we see significant changes as well. The inflowing water warmed for several years. In between they are cooling, so there is no clear trend. This has to be followed as well, and therefore we are developing a similar system for the Antarctic Ocean, where we have buoys floating under the ice, transmitting their data when they can return to the surface in the next summer. And with this type of buoys, we can obtain over decades measurements of the Antarctic Ocean under the sea ice and see what has happened there in the future. With those data of both hemispheres together, we will validate and improve our models, which will help us then to predict what is happening with the polar oceans in future.